So, hi, awesome people. How you enjoyed the conference so far? Is it good? Yay! Here we go. So, thanks for your introduction. Indeed, it's a very significant moment for me because 2 years ago it was my first talk ever, and now after 2 years I'm back with a new talk. It's pretty cool. So today we're going to talk about network layer in React Native. I prepared some really nice slides for you and hopefully interesting content. But first of all, let me start with 30 seconds of, self-promotion. As you already know, my name is Alexey Kureev. I'm a senior React native developer at a Dutch company called Workspot, and yeah, we're hiring. But despite that, I contribute to React Native, write articles about React Native Apollo stuff on medium.com. So if you're interested, come by, check it out. And, whoa, OK. That was unexpected. Anyway, let's get started. So this talk is going to be about network layer in React Native. And it consists of two parts. The very first one is going to be for everyone who ever was curious about network layer. So no premature knowledge is required. We're going to talk about how JavaScript works on top of React Native, how React Native is like a platform that operates on top of native platforms like iOS or Android, and how this entire system works together in order to fulfill your network requests. So as you can see, everything starts from JavaScript, then it goes to React Native, then underlying native platforms, and then requested resource. But first of all, let me introduce these three APIs that we're going to talk about today. First one is fetch. It's a new kid on the block. XML HTTP requests, probably those people who came to React Native development from the web. You already know about that. And WebSockets. But anyway, there is one thing about all these three APIs that some people might not know. These APIs are not a part of the JavaScript language. So it's not a part of ECMAScript specification. They actually belongs to WhatVG specification. But that's side point. The point is that as far as they're not a part of JavaScript, I mean ECMAScript, it's not the responsibility of JavaScript engine to provide these APIs. So basically, ECMAScript is not something that by design was supposed to work with network. But you're wondering, how does it work then? I mean, we have browsers, and in browsers we can use these APIs. We can use it on React Native. So the trick is that there is such a thing that's called JavaScript runtime. And it consists of two things. First is JavaScript API, which complies with ECMAScript standard. And the second part is platform API. So JavaScript is an embeddable language, and it runs on top of some platforms, right? For instance, we can run it on top of iOS or Android applications. And the host platform, which is React Native in our case, it can actually extend JavaScript runtime. So it can provide some additional APIs to the standard ECMAScript API and whatever we have in our JavaScript runtime. So in this case, it's basically a responsibility of React Native as a platform to provide us these three APIs, right? And that's what we're going to talk about in the first part of this talk. I'd like to iterate through all of them. And the first one is going to be XML HTTP request. Again, those of you who came here from the web, you probably already know everything about XML HTTP request. For the rest, I can quickly elaborate. It was invented by Microsoft, I think, long time ago, and then later on adopted by literally all browser vendors, I think. And implementation of XML HTTP request can be divided into two parts. The first part is something that we interact with in JavaScript, like a public interface. So every time when we create new XML HTTP request, which is kind of a stateful object that we use in order to request something or send something to the server. It also has like a backend part. And the backend part is actually a platform-specific code that is responsible for resolving requests that we compose from the JavaScript part. And in React Native, there is a model called networking. It's an abstraction on top of like Android and iOS platform. So it's like unified interface that we interact with from JavaScript. And as far as it's like an abstraction on top of like underlying platform, it actually has some tiny implications. It's not 100% compliant with what we G standard. So we have some tiny things that I'm going to talk about in the second part of this talk. But for now, you just need to know that this is something like a self-written implementation for XML HTTP request. The second, basically networking, right? The second one is fetch. And comparing to XML HTTP request, fetch is like new kid on the block. It's just a function that operates by request object and returns us a response object. So they further can be reused. And there is an interesting thing. In the browsers and other platforms probably, fetch is backed by like native code, like platform-specific code. But in React Native, it works a little bit differently. In React Native, it works on top of XML HTTP request, and therefore on top of networking model that is implemented by guys from Facebook. So in the JavaScript, it uses what we gfetch polyfill from the GitHub, and therefore, if you think of implications of that, you need to consider implications of XML HTTP request or networking model, basically, and all the issues that we have in what we gfetch repository on the GitHub. And last but not the least, WebSockets. It's a full duplex communication protocol. And if you think you never ever worked with WebSockets, that's actually not true if you ever launched your React Native application. Because when you start developing your React Native application, what basically happens? You start the packager, and you start emulator or run entire application on the device, right? And the only way how you can communicate between your laptop and, for instance, your device is going to be through the WebSockets. So if you, for instance, enable hot model replacement or hot model reloading, every single time when something changes in the file system, there is a channel, like WebSocket connection. Every single time happens on one of the sites, signal goes to React Native application, and it reacts on it. Basically reloads it or replace model or literally whatever. And as far as it's like very different beast comparing to XML HTTP request, it doesn't use networking model. It has its own model called WebSockets. And again, it's also implemented by Facebook, and therefore, it's not like 100% compliant with the standards. So let's recap what we were talking about in the first part. We have JavaScript. It operates on these three primitives, these three APIs. All these APIs are backed by something on React Native platform, and then it goes to underlying iOS or Android implementation. For instance, for XML HTTP request, it uses NSURL sessions on iOS and OKHTTP library on Android. For WebSockets, I believe it uses NSStream on iOS and, again, OKHTTP library on Android. So if you're curious, you can look it up by yourself. Anyway, this is the flow of the request, as I already outlined. And now I believe it's a good time to talk about networking issues. So I mentioned a couple of times that we have like implications of this and that. Let's talk about like real stuff. And the first one is going to be about debugging network requests. How many people ever tried to debug network requests in React Native? OK. How do you think? Is it a good experience? Oh, I see. Well, that's true. It has some problems. But let's figure out what problems exactly. In the very first place, how we used to debug our React Native applications. We shake a device or open this dev menu, say like, OK, now is a good time to debug it in Chrome. So we use Chrome DevTools. We can profile memory. We can do, well, literally almost everything there. But there is one tiny bit that we cannot do. We really cannot trace our network requests at all. For some reason, we just go to the networking tab, and we see nothing. It's like, why the hell is happening? Well, as I already said, XML HTTP request, fetch, and other stuff, it's custom implementation of the standard. And therefore, every single time when we use XML HTTP request or fetch, it actually goes to networking model no matter what. So even if you run your JavaScript in the browser, it still connects to your mobile device, sends all the stuff through the networking model on mobile device. And that basically means that Chrome just doesn't know that this request even exists, because even if we run it in the Chrome, Chrome is not responsible for running these network requests, so it just doesn't know. What can we do about that? Well, there are a few ways. First of all, we can use TCP traffic monitoring. We can use something like Wireshark or Charles Proxy. We can set it up. If we're talking about like working with emulators, it's pretty easy. You just set up this tool, and you can filter your traffic there. It just works. And if we're talking about like running on the real devices, it's a little bit more tricky, because we need to configure the proxy on the device and then configure the same stuff on our laptop. And it's kind of tedious, so I'd say not the best way of doing this, right? There is an alternative way of using XHR interceptor. This is somewhat like a private API. So it's not exposed under React Native object or whatever. It's just like, you know, custom thing. So if you really want to use that, you will have to go like through the custom route. So you will need to import it based on the relative path and everything. But you really shouldn't do that, because there are lots of really great tools, like, for instance, Reactotron from Infinite Thread, I believe. And it does everything for you. Like, you install this tool, you hook it up to your React Native application, and every time when you make a request, it logs automatically in the Reactotron. And it also provides you lots of different features, like debugging your Redux and sagas and everything. So you can just use it, and it's pretty cool. OK, so the next one, sending binary data over the wire. And it actually was a problem for quite a while. And I think only now in the version 0.54 it was solved. So if you're not on the edge of development of React Native, it's probably still relevant for you. So what do I mean by sending binary data? React Native never supported fetching or working with binary data. Like, if you want to fetch an object, for instance, it just can't do that, because there is no file constructor or blob constructor till version 0.54 in React Native. So what we actually used to do, we used to make this request through React Native platform, let's say iOS, requested resource, and we used to send back base 64. And that's really kind of crazy, because first of all, it's bigger in the size. Then every time we hit the bridge, like React Native bridge, we really use a string. Then in JavaScript, we allocate space for that. And then probably what you're going to do with this file, I mean, like, it's base 64. Let's say it's an image. You probably want to render it back. So you just got it in JavaScript because you requested it from JavaScript. And then you send it again through the bridge to React Native because you want to render this image, let's say. Or probably you're working with like audio files or videos or something like that. So if you're trying to fetch something like a binary file, you really go through all this flow, which is kind of crazy. But hopefully, nowadays, it's all solved thanks to guys from the call stack, I believe, mostly. They implemented this file constructor, blob constructor. It's now merged in, and it's really, really awesome. So now you don't need to use anything like React Native fetch blob or any kind of other polyfills in order to work with binary data in the proper way. You can just say, like, OK, I'm going to use this ain't going to work. So finally. The next one, credentials policy. So I'm not sure if you know, but native platforms, when we talk about like network requests and cookies, for instance, iOS and Android, they always send cookies. Every single time when you make a request to the same resource, it preserves cookies, send them over, it just works. But here is one thing, like in the web standards, if we like consider fetch, let's say, by default, fetch doesn't send any credentials. It doesn't send cookies. So you need to be really explicit, saying like, OK, I want to send it. But how we treat React Native? Is it like native, or is it like more like a web? So we have two different standards, and the decision was made to comply with the web. So we really need to be specific about what we want to send. However, there are still some issues with Android. Like, if you want to say you don't want to send any cookies on Android, unfortunately, there is no straight way of doing this. Usually, you would say something like credentials policy emit, but it doesn't really work like that. So what I'm trying to say is that like, if you really want to manage your cookies from JavaScript, you need to install additional package for that. If you don't want to send cookies with your Android phone, then you probably also need to install additional package just to clear cookies before you send them. And it's kind of suboptimal for now. But you really need to be aware of this situation, because this is something that we face from day to day. I like to say additional big thanks to this guy, because he actually managed to draw all these fancy illustrations, which is quite cool, and I'd like to have a round of applause to this guy. OK, theoretically, it's supposed to be the end, but I would like to ask you if you have any kind of questions or something that you would like to know. Wow. It's like, either everyone understood everything, or no one understood shit. Just like. So, what do you say? OK, I really hope you understood everything. Whoa. OK, then that's it. Thank you.